Okay. So I'll share my screen and then we'll get right on it. Okay. Right. So this is going to be a little run through how I include visual content in, or how I prepare visual content to prepare in presentations and documents, trying to avoid the file size getting absolutely humongous. Is this the be all and end all? Probably not, but this is something that works. So I'm going to demo a couple of things, but I'm going to run through them quite quickly. So don't if you feel it's useful, don't try to take notes. I'll provide you afterwards with like a step-by-step guide of the various things that I'm going to run through quite quickly in this presentation. So just kind of sit and watch as you were. So some of the common problems with including visual content in documents is just the sheer file size of a document. Even if you only, in inverted commas, include images, the file size can get large quite quickly, which makes sharing of the document really difficult. You can't email it. You have to use a file sharing service, Dropbox, something else. Sometimes it gets even bigger, and then it might actually be a problem to open the file either on your own machine or on somebody else's machine. And also presenting in case of PowerPoint presentations might actually be a difficulty because it takes ages to load, and then the transition between slides might take forever. Another problem is videos that you've spent a lot of time recording the data, making the video, including the video in your presentation, and it just doesn't work, which is really disappointing. And yeah, a lot of wasted energy then. So quite often it's a case of codecs being missing on another machine. So it can be as bad as an incompatibility between the program that you use to make the video, let's say Amaris, and then another program that you want to play the video with, for example, Windows Media Player, on the exact same machine. There might be a mismatch in codecs there. And never mind incompatibility between operating systems. So these are the two main things I want to address today. So keeping the document file size manageable. Something you can think about and should think about from the very beginning is what's the document type that you want to put the visual content in? Is it a Word file? Is it a PowerPoint presentation? Is it a poster? That'll determine what kind of images you need to prepare, or how you need to prepare the images to include these things. So, and for these different document types, you need to have a think about what is the reasonably largest number of pixels required for the item to display well. If you turn it the other way around, how small can you make your image and get away with it still displaying well, but saving on file size? So if you think a projector has about 2,000 pixels by 1,000 pixels, HD video projector. I know not a lot of people are using these at the moment. Monitors, on average, some have bigger monitors, some have smaller ones, but on average, they're also about 2,000 pixels by 1,000 pixels or less. So really, if you want to display an image full frame, like your whole slide is your image, you don't need more than about 1,000 pixels for your image. If you want it to be half of the size of your monitor frame, it's only 500 pixels you need. If you make a multi-panel collage or montage, and it's a third of a frame, it's only about 330 pixels, and so forth. So really, you can just have to think about that, and when you prepare your images, and just keep that in mind. So reducing file size in different image processing softwares. Imaris is a bit of an odd one, but it's possible. So what most people do, me included, is you work on your data with the software in full screen mode. So you have your image data here, and this is your whole data. If you take a snapshot, this is a function in Imaris to just take a picture of your image. If you take a snapshot, this is what you get. So you've actually got a lot of black pixels left and right of your actual image data, which are wasted pixels. They take up space, but they don't tell you anything. And if you think it's like, oh, I'll just chop that off afterwards. Well, this is where your scale bar is. So it's actually in the area that you would probably want to chop off. So this file, the way it is 1.4 megabytes. If you just adjust the size of the application window on the screen to make it smaller and actually make it a square around your image data, which is quite often square because it's a camera-based detection system, or even on a confocal, you usually image with square images. Just put your image window tight around your data and make it smaller in the first place, and then you get an image with your scale bar within your image data, and the file size is nearly half. So this is not the most intuitive way of going about it, but this is something you can do in Imaris. Reducing file size in Fiji, there are different ways that you should all consider, if possible. You could crop your data, cut off black pixels that you don't need, or things that are in view but you don't need to show them necessarily. Reduce your number of pixels and change the image type. So I'm going to temporarily abandon the presentation and do a bit of a demo. So cropping your images is in Fiji is really simple. You've got your image here, your image data. This is 3-channel data. You draw a rectangle. If you can't see my screen, please let me know. You draw a rectangle, you right-click in here, duplicate, pick your channels if you don't want all of them, and there you have a cropped image with your 3 channels. And the file size here was 21 megabytes, and on this one, it's now 12. So this, just cropping alone, makes a massive difference. And all you've gotten rid of is basically black pixels. The next thing you want to do is reduce the number of pixels. So Fiji is really helpful. It shows you a number of bits of information up here. So here it shows 33.3%, which is the zoom of this image. So the image is actually 3 times as large as this, but on this screen, it is displayed as 1/3 of the size. So if you think about how big do you want your image on your presentation, do you want it to be this big, or maybe this big, or maybe even smaller if you have multiple panels? You can see, so this is about 16.7%. Maybe we'll make it a bit bigger. It's probably about 25%, so a quarter. So you would only need a quarter of the pixels that compared to what the image actually has for it to display well. So you can actually reduce that. You go to image, adjust size, and then you've got to do a bit of maths. How many pixels do we have here? So it's about 1200-ish. Image, adjust size, 1200. That's very helpfully told me that. So if you want to reduce it to a quarter, so put it about 300, and there you have it. Your image is now smaller, and it only takes up 884 kilobytes as opposed to 16 megabytes. So this is getting rather smaller, which is nice. And then there's another thing you can do. This image has a bit depth of 16-bit, which you can reduce down further. For single channel data, you go image type, you go down to 8-bit. So this is now 295K. Sorry. Delete that, not delete, reduce that to 8-bit, it's 147K. And then this image, if you want to include that in your presentation, copy and paste. And when you include it in your presentation now, this is the number of pixels that we've set. Had we started with the original number of pixels, let's say here, if you just straight up copy and paste that into PowerPoint, it'll be much bigger. Sometimes it's like absolutely humongous and you have to reduce it down from something like 40 centimeters down to the file in your, or down to the size of your slide. So this is now a really nice and small image, and you can't actually tell the difference between the original and the downsized one. You can go one step further if you have multi-channel images. So if we make that the composite, so these are the 3 channels just overlaid on top of one another, and you wanted to reduce that, then this is now an RGB image and it's quite large. If you wanted to scale that down as well in terms of the file type, you go for 8-bit color. This is something else you can do. And it looks a tiny little bit more dull, and it doesn't work for photographs because it scales down lots of possible colors to 256. So that it can sometimes cause problems. But if your image still looks decent afterwards, it's worth doing this. So this resulted in a much smaller file, 3.5 megabytes compared to 16, what it was before. So these are different things you can do. These are individual bits, and where it is the most powerful is when you say you make a montage of multi-channel data. So if we open this again, the whole file, and I've made a little script just to make montages a bit easier, because they're actually, it's quite a clicky way of going about it. But in the document that I'm providing, all the clicks that you need to do are listed in there. Okay. There you go. Yep. So if you open the file that you want to make a montage of, and you run the script, so here we resize the image 300 pixels. That's round about what we said before. You can have a scale bar, 10 micrometers. Well, it doesn't make that much sense. We can make that 100 because the image is about 600 by 600 micrometers. You can choose where you put your scale bar, what color it is, all sorts of things. I want a 4:1 montage at the end. So here we go. This is the final montage. This is the first channel, which was magenta, the second channel, which was cyan. Single channel data, please, please, please always display in grayscale. This is the transmitted light, and this is the merge with the scale bar. So this file is now 354 kilobytes. So it's nice, it's small, and you can easily copy and paste it into a PowerPoint presentation, and it's a reasonable size on your file. If we compare that to the original file not downscaled. So I don't remember how many pixels. This is smaller. Okay, we need to open the original again, which is fine. So this is 1920. So if we take away all the downscaling, so we're not resizing the image and we're not changing the color from RGB to 8-bit color, then the montage is 21 megabytes compared to, what was it, 600 kilobytes. That's orders of magnitude in between, and you can't really see the difference. It just makes a difference for the file size. Okay. Right, I've rambled on for this enough. So this script, I will provide a link to this script so you can use that. Or you're more than welcome to use it. You don't... I recommend you have a look at the sort of step-by-step guide that I'm going to be providing, just so you know what's happening in the background. But it's a lengthy way of clicking your way through it, which is why I've written this script, so I don't have to spend those minutes doing that every time I want to make a montage out of a multi-channel image. So much about including images. So you want to use all the three different ways of reducing it: cropping, reducing your numbers of pixels, and reducing or changing a file type. Okay. Now, moving on to animations. The cropping, the numbers of pixels, and the image type applies in this case just the same as it does for single images or even multi-channel images. Something else that comes on top here is the number of frames. So think about how many of your frames of your, say, Z-stack or your animation do you actually need? A good rule of thumb is you want your animation not to look like it stutters, like you want it to run smooth. So you need the minimum number of frames for it not to run stuttery. So reducing file size in Amaris for animations is Amaris lets you record animations, and you can set certain key frames, which is a view or an addition to surfaces or spots or something you've created, and then you can choose how many numbers of frames are in between your key frames. I don't know who's used Amaris when I took the screenshot, but 1,000 frames for a 360-degree horizontal turn is way too many frames. So this is about 2.7 frames per degree turn. You do not need that. You might need 1 frame every 10 degrees or maybe even every 15. So think about how many frames do you reasonably need. You can use this button as like a preview to look through your video and reduce the number down just to the point where it's just about not stuttering. And as I said before, adjust the screen or the window size of the application to get a tight crop around your imaging data as well. And then Amaris lets you save as 2 different video file sizes. One is AVI, which is always big and a massive problem in terms of codec mismatch and compatibility. The other one is MP4, which is not too bad. It's encoding with the H.264 codec, which is fairly common. It's frequently used, playable on a lot of devices, but it's not universal. So my favorite export file type in Amaris is a TIFF stack, which is just a bunch of images. So every frame is an individual image. And then the world is your oyster. You can do whatever you want with those images. And I usually then process these in Fiji, where you can make animated GIF files. Animated GIFs are pretty ubiquitous. You've got them on your social media, you've got them in your messaging service, you can see them in any browser, which means they're also cross-platform in terms of operating systems. So at the moment, really, you can't get away from an animated GIF. So why not use them for your microscopy data or other imaging data? Some pros for animated GIFs: they're small in file size, opens in any browsers, and you don't need a special plugin, and in particular, you don't need a dedicated player. You can create them in Fiji, and they embed fully in your PowerPoint presentation. There are limited colors. So you've only got a color depth of 256, which is sometimes a problem, but most of the time it is not. You've got, I said few more steps, but just one extra step to include it as a video in PowerPoint, but it is more than just possible. So back to Fiji for a quick demo. So this is a Z stack. So I want to make a video where it's sort of moving through the Z stack. So one thing you can say for sure is a Z stack that you want to use for image analysis has way more frames than you would need for an animation. And for a time series, the difference isn't quite as large, but you might be able to get away with less frames than are in your, like, slices that are in your time series. So hopefully this opens soon. And then we can continue from there. So first thing you want to do is make a substack, and you only want to take every second, every fifth, every 10th, every 20th image, whichever gets you to a point where the animation still looks like it's running smooth, but not stuttering, but you're massively reducing your file size. Okay. And you do want to crop as well, if possible. And reduce your number of pixels, just as we did for the individual image earlier. And change the image type at the end. Come on, Fiji. Okay, I know what I've done wrong. Sorry, apologies. I should have opened this as a virtual stack rather than loading it into memory. So I could show you that, because this is 8 gigabytes big. So import diff virtual stack and demo files. This guy. This does not appear. Yes, it isn't. Okay, there. I've forgotten to tick that box. That's fine. Here we are. That's what I expected to happen. So we have got imaging data. It's lots and lots of frames. We want to make this composite. But these are way too many frames for an animation. So in order to substack is image stack tools, make substack, and then you can go, I want like every 12th image. That'll give you about 50 images in the end. I want both channels. Okay. And then we'll get a much, much smaller stack to play with and make an animation from. Here we go. So if you scroll through this, it still looks pretty smooth. It doesn't look too stuttery, but we've shed about 90% of the images. So really think about and have a play. How many frames do you reasonably need to make an animation? Or we can skip the last couple of slides because they were, or last couple of frames because they were black. Ooh, good. Okay, so we've got this. So we'll put a scale bar in there. Something like this, label all slices. Then these are still lots and lots of pixels. So image, adjust size. So let's say 400 or 500 pixels because you want to put it in the middle of your presentation. Okay, this is resizing the whole stack. Lovely. And then we want to go somewhere where it's a bit brighter. Image, type, 8-bit, no. To do this first, image, type, 8-bit color. Okay, we're at 11 megabytes. It's much reduced from 8 gigabytes down to 11 megabytes. That's not quite 3 orders of magnitude. You could still crop this actually. I forgot the cropping, and then it would have been even less. But you see, within a couple of clicks, you can shed lots of gigabytes, really. So now for the final point, saving as animated GIF. So you've prepared your stack, you're happy with everything that's in it. You've added a scale bar, and then you save as animated GIF. You want to use the lookup table load from current image, set delay in milliseconds. So this is 1/over frames per second. So if I put 100 here, it'll be 10 frames per second. And I want it to loop continuously. So I'll put a 0 there. Okay. Give it a file name and save. And then I'll show you how to embed this into your PowerPoint presentation. You should always check it looks all right. So you can open in Fiji, open in most sort of video photo viewers, open it, but also any browser. There we go, it's playing, it looks pretty good. So here, insert video, and video on my PC. And then the only step you have to do is here it gives video files, but animated GIF is not one of them. So if you just click all files, here's your GIF, insert. It gives you a message. It's upgrading this media. Just wait for this sort of status bar to complete, and then this file is completely embedded in your PowerPoint. So if you want to send the PowerPoint to anybody, you don't have to make a folder and it has the video in it and the PowerPoint presentation and some other stuff in it. It's all part of the PowerPoint. So you can zip the PowerPoint and send it to somebody if need be. Depending on how large your video is, this is now 1.4 megabytes. It's not too bad. This might sometimes take a little bit, but here's your video included in the PowerPoint. You've got video options here in click sequence, loop until stopped, rewind after playing, all sorts of things. So you have video options on this one once you've included it. And you've got a nice small file size at the end. Plus, you don't have to mess around with it's like, which videos have I embedded it or included in this PowerPoint presentation? Also, which ones do I have to copy and paste into a folder to send to somebody else? So this was a quick run through of that. Insert video here. So this is what I've done. So I've gone through a lot of things really quickly because it's only half an hour and I didn't want to ramble on for too long. But there is a PDF guide, including all the steps that I've just done, written down bit by bit and exactly where to find them in Fiji. So there is a new Tech Bites page on the CCI webpage where you can find that PDF, download it, and then have a play along. The Fiji macro for making a montage from multi-channel images is on my GitHub page. There is the link to the GitHub page in the PDF, and the recording of this Zoom video will be on the CCI YouTube channel very soon, once it's been processed and I've downloaded it and uploaded it to YouTube. And I'm more than happy to answer any questions.
Thanks, Marie. It was very, very clear. And I was just having a look at the chat. Didn't find many questions, but just because it was incredibly clear, everything. I have a quick question myself. So as a starting material in terms of images, what would you recommend? So which kind of formats of the files is the best?
What do you mean, formats?
From the point of view when you acquire the image in order to start this kind of reduction process.
So just open the raw file.
Yeah. So whatever.
Open the raw file. Yeah.
Okay.
If it's a CZI from the light sheet, that's one of the files I opened. It was the raw data file. You can, if you didn't want you had a transmitted light channel, but you didn't want it, you can substack it to that, or reduce and skip whatever channels you don't want, or frames or something else. But you can start with the raw data. You don't have to prepare it in any way.
Thank you. This was
you could change it. You could do some background subtraction, this, that, the other. You can do all sorts, but you can just start with the raw data.
Okay. And probably I should just remind that, whenever you have a question to Marie, you can pop them with a mail also after this
Yes.
small tech bite. Well, I'll give the word back to you, Marie, if you want to wrap it up or whatever.
Yeah, so have a browse through the PDF if you think that this is something you would like to do. As I said, you're more than welcome to use the Fiji script. If it doesn't work, or there's an option that you think you would like there, then let me know. It can be adapted, and we'll go from there.